All right, guys, so we're going to do some more examples of Lewis structures now that we have, gone over all the different exceptions that can occur, so we can have, a wide range of different types of problems. So the first one I wanted to do is phosphorus pentafluoride, PF5. Calculate the number of valence electrons, 5 for phosphorus, 7 for fluorine. There's 5 of the fluorine, so 7 times 5 is 35, plus 5 is 40 valence electrons. Most electronegative atom is fluorine. We want electropositive phosphorus in the center. And there's 5 of them, so we're going to connect the 5 fluorines. And right away, you notice that we violated the octet rule with phosphorus. It has 2, 4, 6, 8, 10 valence electrons, but there's nothing really we can do about that. It's okay because phosphorus is in the third row of the periodic table, so it has some d orbitals it can access to accommodate those extra 2 electrons. But we still need our 40 valence electrons. We already have 2, 4, 6, 8, 10 accounted for, so we have 30 left. And to accommodate the octet rule for fluorine, we're going to need to add 6 valence electrons. So if we add 6 valence electrons to all 5 fluorines, that's going to be 30 valence electrons, and that gets you the correct 40 valence electrons that you need. So it's expanded octet. Obviously not a super stable molecule if it has an expanded octet like that, violating the octet rule, but that's the best Lewis structure that we can draw. All right, let's do some more examples. I want to do boron trichloride and also BH4 minus together. Okay, so let's do valence electron counts for both of these. Boron is 3, right? And chlorine is 7. It's a halogen. There's 3 of them. That's going to be 24 valence electrons. Boron again here is 3, and there's 4 hydrogens, 1 good for 1 each. And we also have to add 1 because we have a negative charge. And so that's going to get us 8 valence electrons. Boron is more electropositive, less electronegative than chlorine. So we are going to have a situation that looks like this. And let's set up this one as well. BH4 minus. Hydrogens never can be in the center because they're duet rule, right? And so it's going to look like that. And let's see. So we've used here 2, 4, 6 electrons, and we have 18 electrons left because we had 24 valence electrons. So if we put satisfy the octet for all these chlorines, we are going to get 2, 4, 6, 8 for each chlorine. There's 3 of them. That's 24. So we are good, but we'll notice that we violated the octet rule for boron. But remember, boron's one of those electron deficient ones. Boron can have oftentimes only 6 valence electrons, and remember, beryllium can oftentimes have 4 valence electrons. Those are 2 common exceptions. They're very electropositive elements. I just want to show you that not always will it have 6 if it's boron, or always have 4 if it's beryllium. Here, look, it has 8. This is everything. The octet rule is fine on this. There's duet rule for hydrogens, and there's 2, 4, 6, 8 for boron. We needed 8. So, not all the time will you violate the octet rule on these electron deficient molecules. Let's stop there for now, and we'll do more examples in the next video.